In this video, we're going to talk about JavaScript closures. So to just understand JavaScript closures quickly, just think of it as a function that remembers variables from where it was defined. So like even after the outer code has finished running, it's still going to remember. So by remembering, it means that there's some sort of live reference to that variable and not really a copy of that variable. I'm going to give you just a quick mental model to help you understand this JavaScript closures here. Let me just change the color. Awesome. So I want you to imagine that you have a lunchbox. Let's say this is your lunchbox here. Okay. I hope this is our lunchbox looks like. Let me just try to make it a little bit nicer. Okay. So let's say this is your lunchbox right here. I want you to think of your lunchbox as a set of variables. I'm going to change this. I want you to think of it as a set of variables that is inside a bag. And this is the bag, right? This is the bag and this is your lunchbox. Think of this lunchbox as a variable and the outer bag that you have, which is this one here, where your lunchbox is in. I want you to think of it as a function. Now, when you hand someone just this lunchbox that is in here, think of this lunchbox now as an inner function. When you hand someone this lunchbox, it still contains the food that you had packed in your lunchbox. So even if the bag is gone, the food is still there. Now, this is what closures are. So closures are this lunchbox. So once you basically hand someone your lunchbox, just assume that this is the lunchbox here. Okay, let me just try to make it a little bit nicer. So once you give someone your lunchbox, this lunchbox, yeah, it still contains the food. So which even if the bag is gone, the lunchbox is still there. So closures, I want you to think of these closures here that we're talking about. Think of these closures as the lunchbox that is still remembering what you packed because your food is still inside of this lunchbox. Okay, I hope this makes sense. Just to try and visualize a lot better as well, I'm going to have three levels. So you have, this is what you have here. You have your global. So you have the global scope. Think of it as the global scope is this big box here. Then instead of this global box, there is another box here. And this other box, think of it as the one that contains your lunch boxes and everything. Then there's another inner box here, or you can even call it as an inner function. This is the one that remembers what you have using closures. Now the key idea here is that JavaScript scope is lexical in nature. What you mean by that is that it is decided by where that code has been written. So an inner function gets a scope link to the variables that are around it. Does that make sense? I hope it does, given the kind of explanation that we have here. Now, let's just think about the smallest possible closure. What does that look like? And I want us to look at this in terms of code. What does the smallest possible closure look like? I'm going to create a function and we'll have a function and we'll call this function outer. This is how you get the smallest possible closure. And in this function, we're going to have a count. Let's say we have a count and we assign it a value of 0. And then we're going to have another function in here. So this other function, we'll just call it inner. And this inner function is going to also be used to update count. So I'll just use count here. Then it's going to be just count plus 1. And we're going to console.log. We're going to console.log this count. And I'm just going to add the semicolons that I didn't add here. Okay, I think we're good here. Then once we have this, once that inner function has increased the count, we can basically now return inner like this. So I want you to think of all this function that we have this way. What we have here is this is the local variables, but this variable is local to the outer function, as you can see. So I'll just say here, this is local to outer. This is a local variable, but it's local to the outer function. And what we have down here, the line 3, this is the inner function. So the inner function is defined inside of outer. We can already not outside, but inside. This is defined inside of outer, that inner function. And what you have as the count, which is the one that does the incrementing that we see here, this is the one that this uses the outer variable. So outer's variable. Remember, the count in line 2 is in the outer function, right? Then of course we are printing the count here, and finally we have this return in line 7. This return basically just returns the function itself. I'll just write here as a comment as well, returns the function itself. Returns the function itself. Now, what does that mean generally? To understand what it means, we first need to, of course, call the outer function, right? So I'll just call the outer function. I'll just create this function and call it fn, and then call this outer function. When I call this outer function, this is basically now, this is just to understand how it is going to run. I'll write it as a comment. The outer function that we have, which is from line 1, the outer function is going to run once. So I'll just say outer runs once. And once it runs, it's going to return the inner. Now, if you don't understand the return keywords and how they work, just refer to a previous video in this series. But once you have this, I'm now going to just quickly print out not print, but call this fn. Remember, this fn, which is the variable that we have here, calls the outer function, right? When you call the outer function, it returns the inner function, which means we now also have to call the inner function because that is what is returned. So that's why we're assigning in this variable here, fn. So we have to call inner. And then I'm going to call it multiple times so you can see what, I think twice is okay. Now, this is what we expect as the answer. Remember, the count starts at 0. Because the count starts at 0, let me just add the semicolons here. Because the count starts at 0, that means this is going to give us 1, this is going to give us 2, and this is going to give us 3, like that. But let's run the code to see whether all this makes sense. So we're going to just run node. This file is called closures.js. When we run it, you see we get 1, 2, 3 as the results here. And the reason we're getting this count this way is because of how this works. So remember, count is set as 0. To increment the count, you have to call the inner function, which is ideally what we are doing in line 10. We are not line 10, but rather line 12, 13, 14. We are calling the inner function. So once the count is 0, this function runs, and then we return the inner. So once we call the outer function, it only executes once and returns inner. Now, when you call the first function, it's going to increase the count by 1. Since it has already increased the count by 1, it means that the count has been updated. So the next function is also going to update by 1 as well, and then update by 1. And just that chronological order of events is going to proceed like that. But why did we write our code this way? We write our code this way because this count variable is not a global variable. It is hidden inside of the outer function. Now, we do this as a result, of course, understand the whole aspect of data privacy with scope and all that. Then when we have this inner here in line 7, we're returning this inner. Returning the inner is how we basically export the behavior that still has access to the count. Basically, think of it as some sort of encapsulation. We are hiding information, and then we're only revealing the only information that we want to reveal to the outer, to the people who don't have access to the inner function. So we are returning this so that we can export the behavior of count, because it's the only one that sees this behavior of count. So each call of this fn updates the count variable that we have in here, as we said, because the inner itself, this inner function from line 3, is the one that holds a reference to the count. Okay, I hope this makes sense. If it doesn't, please just play back this slowly. In case there's something that doesn't make sense, let me know in the comments below. But that is simply how this works. So if you call the outer function, like we've done here, if we just call it again, we're going to get a new count. If you call the outer function, we're going to get a new count. So to understand the aspect of closures in this context, closures let you create multiple independent instances with a private state. Because if I call this again, it's going to give me something else. It's going to create a new counter. Just to show you what I mean here, I'm going to just copy, and I'll just have it down here. And then I'll just call this maybe fn1, right? And I'm going to call this fn1 again. So fn1, I'll just call it, and we'll just call this 4 times. We call it 4 times. Then if we run our code one more time here, this is what you get. You see, the first outer gives us 1, 2, 3, which is what we have here, 1, 2, 3. Then you'll notice this other one also gives us 1, 2, 3, 4. The reason it's doing this is because of closures. They let us create multiple instances, multiple independent instances with a private state. In this case, this is the private state we're talking about. So I hope this has made sense in terms of what closures and or rather what closures look like. But when you looked at this, when you looked at the board here, we talked about the aspect of a global state. Ideally, there's this outer box now that contains everything. And us to discuss that in a moment. So there's a global state, and then there's a private state. Okay. So global states are risky, and these are the ones that we're used to in the code that you've been writing since the beginning. You've been mostly using a global state, but global state is risky because any part of an application that you have has access to this global state, so it can mutate even the things that you don't want it to mutate. Mutating is basically changing. So you don't want a case whereby every part of your app can change the global state. When you get to learn React, we'll talk about state management, and it will make a lot more sense. But in this sense, just think of state in terms of the scopes that we're seeing and the closures that we're talking about here. So, and us to talk about what global looks like. Okay. And in this case, okay, we'll just maintain using this here. So I'll just create I'll just call it before so that it makes more sense. This is when I talk about global. So we can create a variable, and let's say we call this a variable clicks, and then we have it as 0. Think of it like a simple count application. Then I'm going to write a function, and I'll call it this function handle. I'll just call it handle click. And what this function is going to do, or what the function does, is it basically increases count. So we just increase this clicks plus plus. Then we go ahead and console.log how these clicks increase, right? So I'll just say clicks, and then I'm going to have it as no. Okay, let me just leave it as this. I'll just use it here. I'll have this clicks variable here, like that. Now, what you have here is what you mean by global state being shared. The clicks variable is in a global state. As you notice, it is not enclosed by anything. So it is in a global state. Now, the reason why this is bad is because, like you mentioned, any other code can change the clicks variable in line 23. It can change it accidentally, even when you don't want to. So, which makes it a bit hard for you to even test your application. But if you call this handle click function, I'll just call it here just once for now, so you can see the results. Then when you run our code, you see we get clicks is 1. Then we can just call it multiple times, right? And then we run our code, you see it's clicks 2, 3, 4, 5. Okay, then we can create another function, and I want you to say this other function. I'll just create it down here. Then I'll call it handle click, let's say click 2, like that. What this is going to do is that it's still going to increase clicks, but you'll notice how different this is going to look like if we decide to call it here. So this function is called handle click 2. And then once we save, then we run our code, you'll see that it keeps on updating the variable, the variable clicks, which is different from what we saw earlier, whereby when you're talking about closures, we're able to create a new state every time. We're able to create a new independent instance every time with closures. So now here, if we call this, if we just have this multiple times, it will just keep on updating this other state. And this is a different function. So just imagine the kind of a mess it's going to create when the scope of your application increases and you have a really complex application. So this is why it is bad for you to use a global state in most cases. But this function, we can create it in I'll just create a variable here, not variable, but a comment. I'll just call it after. But what happens to this once we do, or rather apply closure to it, right? So I'll create a function, and I'm going to call this function, let's say make click counter. I'll just counter, but make click counter just sounds okay. So we'll create this function, and in this function, we're going to do the same thing we did earlier. So I'll create clicks. So we'll have clicks. Then this is going to be, I'll just assign it a value of 0, and we're going to use it, we're going to return a function. So there's a few things you can just create a separate function, but it's okay, just show you the different ways that you can write these things. Instead of returning the name of the function, you can just return, then write the entire function that you want to write. So you can say something like this: return function. I'll just call this function handle click, and then we're going to use again clicks plus plus, and we're going to console.log, and I'll just say I just got something like that so that you can differentiate it from the other. Then we just pass in clicks like this. This is what this function looks like, and we can now go ahead and call it. We're going to call it two different ways, right? So you can create like multiple counters when you want to, but for now I'll just call the make click counter. Remember, make click counter. Okay, I need to assign it to a variable. So I'll just call it, it's a home, and just, yeah, I'll just create a variable called home, then call the make click counter. Remember, when you call this make click counter, it returns this other function, which is the function that handles click. Okay, keep that in mind. Then when you come here now, what we call is the home, which is the handle click function that got called there. So if you call this multiple times, let's say we just call it twice, and then we clear this and run our code, you'll notice that it says clicks 1, clicks 2, okay? But what if we try to create another instance, which is kind of the same thing as creating another function to still handle this count? So we can create another instance of this function. So I'll just, okay, I'll just copy paste this, and then I'll call this home1, right? Then when you come here, we call this other function and we just call it home1. Let me add the semicolons that I'm missing here. Awesome. Now, when you run this code again, you'll notice that it does clicks 1, clicks 2, and then it still goes to clicks 1 because there's a new independent instance that has been created by this line 53. So again, the same thing that we were explaining earlier with the outer and inner functions that we wrote. The reason why we write these things this way is because for the clicks, like just the same explanation as earlier, we encapsulated this clicks function, not function, but the clicks variable. We encapsulated this clicks variable down here in the after. We encapsulated the clicks variable inside the make click counter. So think of it as a factory that basically produces or executes all these other things here. And each call that we make is going to create a fresh state. It's going to create a fresh, think of it as a box of state. So kind of the same boxes that we talked about here, like lunch boxes. So it creates basically a new lunch box kind of, and a function that can access that lunch box. Okay. So a takeaway from here, a major takeaway that you should take from here is that closures are a lightweight alternative to classes for encapsulation. Now, we haven't talked about classes, but it is something you're going to encounter later on. But there's the concept of encapsulation, which is a term I used earlier on. Encapsulation is the concept of information hiding. It's basically hiding information so that you only reveal what you want a user to see. So think of it in terms of, think of an ATM. In an ATM, you can only see the numbers that, like, this is your balance. You can withdraw money if you want to. You can do all the other things that you do in an ATM machine, but you can't see the underlying code or the underlying operations that are happening behind the scenes. So we're kind of doing the same thing here. So think of these clicks as the function that the variable that contains the balance, your bank account balance, but you can't see it. All you can see is this function that you call for you to see what that balance is, and the function that you call is that button that you click on in an ATM. So that is what closures look like. They're very important. Now, Closures is something that I guarantee you're going to be asked in a job interview. I guarantee this. You will be asking in a job interview, what is closure and how do closures work and all that. So make sure that you take some really good notes and understand this. What are some of the common challenges or mistakes that people make when they're dealing with closures? We've talked about for loops so far. So for loops basically has this kind of a trap that it sets up for you. And the trap that it can set up for you is, for example, I'm going to just create, I'll just say, okay, I'll just create call bugs as a comment there. So we'll have a for loop, and I'll just get a for loop. Then we're going to use the var keyword here, and I'll just say I'll initialize this. Remember how for loops work? There's initialization. Okay, let me just do this again one more time. So we do var, and we're going to initialize it to 0, and we're going to do a condition. Let's say I less than a value like 3. Okay, this should be a semicolon here. I used a comma, and then we're going to have an increment like that. When you have a for loop like this one, you can create a function. So you can actually, let's use the set timeout. So you can use the set timeout here. Then this is going to take in, of course, another function, which is going to be a handler. So it will take in an arrow function. And we've talked about arrow functions again before. If you need a refresher, please refer back to the arrow functions video. Then we just do console.log, and I'm going to have a var here, and I'll just pass in I as the variable, and then I'm going to set the timer to 10. So it will update this after every 10 seconds. That is what the set timeout function does. Then let's run this code now. Let me clear this and run it. You'll see it gives us var 333. Okay. Now you're wondering, why am I getting 333? Remember, we said about bugs. This is a bug that we're implementing. The var keyword itself, as you know, in this case, the var keyword is function scoped. What that means is that for every callback, it's going to share the same I value because it is function scoped. To fix this, the preferred way that you can fix this is, I'm sure you've already thought of it. You're even wondering why I use the var keyword, because I've told you before not to use it. That is the simple fix here. The simple fix here is just to use the let keyword. The reason we use the let keyword is because the let keyword is block scoped. Okay, let's run this code again. Now you see it says var 0, var 1. Okay, I'll just actually change this to let as well, just so that we don't create too much confusion. You see now we get 0, 1, 2. I hope this makes sense. When you use a var keyword in a for loop, the var keyword, that becomes a bug because the var keyword is function scoped. Because it is function scoped, it means that every callback is going to share the same I value. Okay? It's going to share the same I value. I hope that makes sense. But for a let keyword is block scoped. So it is confined to the block that you've already created in the for loop. So it's going to basically get a new value after every iteration. So in this case, 0, 1, 2. Okay. There's another way that you can fix this. You can fix that bug by using what we refer to as an immediately invoked function. An immediately invoked function is a function that kind of calls itself. Okay, this is what an immediately invoked function looks like. I hope you're taking notes. Again, whenever you need to just refer to, not really refer, but whenever you need to just uh, move a step back, just backspace or something, back step to see the previous code. But anyway, just proceeding here, I'm going to create a function. Then I'm going to give it a parameter here, which is going to be x. Then this function is going to take this set timeout here. So it'll take set timeout as that, as what it needs basically. So this is not that this function is enclosed inside of parentheses. Okay, this is what an immediately invoked function looks like. So what makes it immediately invoked is because it is inside of this, you can call it immediately like that. Remember, that's how we usually call our functions, by of course adding that set of parentheses. So what this does, and why this is a fix that works for the bug that we introduced earlier on with the var keyword, is because the let keyword creates a new binding of the I value. So for each of the iteration that is going to happen, it's going to create a new binding for the I, basically a new value for the I. So and an immediately invoked function is going to, it kind of takes a snapshot of the specific parameter. In this case, the parameter that it has is x, as you can see here. It's this parameter x here that it has. So this allows basically the it allows us to get the right value right after, because it is taking the snapshot. Like during the first iteration, the x is going to pick the value which is going to be 0. During the second iteration, it picks the other value which is 1. During the iteration, it picks the new value. So it's basically like it's after every iteration, because the var keyword just maintains the same value, but this one is going to pick a new value every time. Okay, let me just run this just to show you that this thing works. We run this and you can see we're still getting the same. Let's 0, 1, 2, 3, or rather 0, 1, 2. So this is what closures look like. There are many ways that we're going to encounter closures later on. There are many production patterns that are going to basically encounter with closures, but this is the best way to understand what closures are and what they look like. Okay, happy coding, and I'll see you on the next one.